In this example, we're gonna look at another game that has no pure strategy Nash equilibrium. So if we were to look at this game, let's say Alice say, I'm gonna play S1. So if let's say Alice plays S1. Now Bob can look at the table and he has to decide between paying Alice $2 or get $2 from Alice. Well, I don't know about you, but if I were to be Bob, I would rather get money from Alice. Now then, if Alice knew that Bob is gonna choose T2, so then she has to decide between paying Bob $3 or getting $3 from Bob. And again, she'd rather get money from Bob, so now she changed her mind and choose S2. Now, Bob knew this, and Bob see, well, if Alice were to choose S2, then why should I pay her $3 where I can just pick the first column and pay her nothing? Yeah, so he changed his mind and instead played T1. So now, Alice say, well, if Bob is gonna play T1, then why would I rather get nothing when I can actually get $2 from Bob? So she changed her mind again, and we kinda get stuck in the same loop. So this is once again a game that has no pure strategy Nash equilibrium. And we can actually kind of solve this with the same method that we do in the last example. So we can use the expected value. So let me actually call that method 1. So which is to use expected value. But in this example, I'm actually going to use another method. So let me actually call it method 2, which is going to use graph. Now, let me do the analysis for Alice first. Now, the graph that we are going to use is going to be a little confusing because normally we think of graph as an x and y axis, right? So x can represent something and y can represent something. Like x can be a variable and y can be the value of a function. But for this analysis in game theory, my x is going to be the probability axis. In particular, this is going to be the probability that Alice plays S2. This is going to be the probability that Alice is going to play the bottom row, and the y-axis is going to be the payoff. So it's going to be, the graph that we're going to look at here is going to be a little confusing because the value of my axis is actually going to be just the probability. And because we knew that the probability is going to be just between 0 and 1, so the value for my x is going to be just between 0 and 1. So it doesn't go any further than this because this represents the probability that Alice is going to play S2. Now, let me actually color code my thing here. So let me actually put S1 in, let me put pink for S1 and let me do purple for S2. So what that means is if x is 0, that means the probability that Alice is going to play S2 is 0. So that means Alice play S1 for sure. Let me actually draw a pink axis here. So that means Alice play S1 for sure. This means Alice plays S1. Let me actually draw this a little bigger. So it goes from 0 and 1. Now, if my x is 1, that means the probability that Alice play S2 is 1. So that means Alice is going to play the bottom row for sure. So my S1 is pink thing and my S2 is now purple thing. And then when x is 1, that means Alice is going to play S2 for sure. So on my purple axis here, that means Alice plays S2. So again, I'm trying to use the xy graph that we normally use, but because the value from my x is just the probability, so I don't really need to draw like the infinite graph where x goes from negative infinity to infinity because I knew that the probability is just going to be between 0 and 1. I mean, you can draw it this way, but we're not going to go beyond the pink and the purple line here because that's the probability that we're going to look at. If x is 0, that means Alice play pink row for sure. If x is 1, that means Alice play bottom row for sure. So for anything in between, for example, if Alice play 1/2 here, that means Alice play top row with probability 1/2, Alice play bottom row with probability 1/2. So that's what the x value means. Let's say if I move this a little bit, let's say it's 1/3. Okay, let's say this is 1/3. So again, the x value is the probability that Alice is gonna play S2. So if Alice ends up choosing this point, what that means is Alice is gonna play S2 with probability 1/3 and play S1 with probability 2/3. Then remember again, the x value is the probability that Alice is gonna play S2. So what's gonna happen here is that because Alice is the one who chooses between the top row or the bottom row, Alice can choose between the pink line, the purple line, or she can use mixed strategy. She can actually do anything in between. So she can use like whatever probability that she wants. So what Alice does is that Alice, let me actually write this in pink. So Alice choose x value. Yeah, because well, the x value is the probability that Alice is gonna play S2. So she can play S2 with whatever probability that she wants. So she can choose any whatever the any of the whatever x value in between 0 and 1. So that's gonna be what Alice can do. Now let's look at this from Bob's point of view. Now Bob can choose between T1 and T2. Let me color code this. Let's say my T1 is blue, and then my T2, this is probably light blue. So let me do this thing then. Now let me focus on the blue thing first. So Bob can see that, well, if he were to play T1, then the payoff is gonna be 2 if Alice were to play pink. So if Alice play pink, the payoff is gonna be 2, and the payoff is the y-axis. So Bob can see that. Let me actually use the color blue. So Bob can see that this point is going to correspond to this point here. This is when Alice plays S1 and then Bob plays T1. Now, if Alice plays S2, if Alice plays purple and Bob plays blue, so that means the payoff is going to be 0. So if Alice plays purple, the payoff is going to be 0. So that is going to correspond to this point here. So this point is going to correspond to the number 0 here. And then this point is going to correspond to the number 2 here. So again, the y value is the payoff. Now, I can draw a line that connects between these 2 points. This is going to be the expected value. So the y value is the expected value. If Bob plays T1. Yeah, and we can kind of see how this makes sense. Let me kind of use the green highlighter here. Okay, so if Alice say, okay, I'm gonna play S1, so that means she's gonna play the pink line. And if Bob plays T1, then we can see that the payoff of the game is gonna be 2, and that's gonna be my y value here. If Alice say, okay, now I change my mind, I'm gonna play S2, I'm gonna play purple. So that means she play purple line. And the expected value here is going to be, the outcome of the game is going to be 0, and that's going to be what we have here. But if Alice kind of change her mind, Alice say, okay, well, I'm going to play the top row with probability 1/2, the bottom row with probability 1/2. Yeah, I can do that because, well, Alice can choose whatever row that she wants. So that means Alice choose the x value, and the x value is the probability. So that means if Alice do this, play the top row with probability 1/2, bottom row with probability 2/2, then that means Alice choose the x-axis, the x value to be 1/2. And you can kind of see that the expected value of the game is going to be half of 2 and half of 0, which is going to be 1, and that's actually going to be exactly the y value that we see here. So the y value of the point on the blue line is going to be the expected value of the game if Bob were to play T1, which is the first column, the blue row here. So let me actually erase this green thing. So then, this is for the blue part. So let me kind of do the same analysis for the light blue part. So if Bob were to play T2, what's going to happen? So we kind of do the same analysis here. If Alice were to play pink and Bob were to play light blue, then the payoff is going to be -3. So that's going to be somewhat down here. So this point will correspond to this point here. So if Alice plays pink and Bob plays light blue, I'm going to get -3. On the other hand, if Alice plays purple, and that corresponds to this line, if Alice plays purple and Bob plays light blue, the payoff is going to be 3. So the payoff, which is the y value, is going to be way up here. Extend this a little bit. So this point here, the y value is 3, so that's going to correspond to this number here in the table. So now I can connect these 2 points and draw this light blue line. So this light blue line is going to be the expected value. So here the y value on this line is the expected value. If Bob plays T2. So now I can kind of turn this table into this graph where Alice can choose the x value. Alice can choose the x value that she wants. She can play the S2 with whatever probability that she wants between 0 and 1. And Bob, because Bob can choose between T1 and T2. So what that means is, for Bob, in this graph game, Bob can choose between regular blue line or the light blue line. Yeah. So if he plays T1, that means he picked the dark blue line. And if he plays T2, that means he picked the light blue line. Yeah. So Alice can choose the x value and Bob can choose the light blue or dark blue. And now let's see how this game is going to play out. And let me kind of erase this part. Okay. Now, let's say if Alice play F1 for sure. Now, if Alice play the, let me actually use color green. Yeah, okay, color green is fine. Okay. If Alice play F1 for sure, that means we are here at the moment. We can kind of see how, well, Bob is going to pick the smaller number of the two. So Bob is going to pay T2 because he rather get $3 from Alice. So if Alice play S1, Bob will pick light blue. So he chooses to be here because that means he'll get money from Alice. On the other extreme, let me actually redraw this. If Alice were to choose S2, so that means we are looking at here. Now, well, if we were Bob, then we rather choose T1 because that means we don't have to pay Alice anything. If we choose T2, that means we have to pay Alice $3. So, and that corresponds to the dark blue dot and light blue dot here. I have to choose between paying nothing and paying $3. So I'd rather choose the bottom one. So again, let me kind of do this one more time. If Alice were to play S1, that means I'm at the pink line. And then Bob has to choose between 2 and -3. 2 here and -3 here. And Bob likes smaller numbers, so he chooses the bottom one. Yeah, he rather get money from Alice. Now then, if on the other hand, because Alice can choose the x value to be anything, she can choose the probability to be anything between 0 and 1. So that means this kind of green frame here, it can move anywhere between the pink line and the purple line. Let's say we end up somewhere, let's see, here. I don't really know exactly the value, but that's fine. So let's say if the if the green thing is here, so the probability is somewhere between 0 and 1. And if we were Bob, then we have to choose between down here and up here. Yeah, down here and up here. Paying a list something or getting money from a list. If I have to choose between the two, I'm just gonna choose the bottom one because that means I get money from a list. And let's say if the green frame were to be here, the probability is somewhere between 0 and 1. Again, Bob has to choose between down here and up here. Well, he rather choose it down here because that means he rather get money from a list. And we kind of do the same analysis everywhere on the graph. And you can kind of see that, well, wherever the green thing is, Bob will just always pick the smaller number. And well, that's because, well, Bob prefers smaller numbers, so he's gonna pick the smaller point of, he's gonna pick the lower point between the two. Wherever this thing is, Bob is just gonna pick the smaller number of the two, and that kind of makes sense. And now you can probably kind of guess already. There is exactly one point where these two lines meet, and that's gonna be when Bob doesn't exactly have a choice. Yeah, because no matter what Bob did, well, the outcome is the same. He can choose the T1 or T2, it doesn't really matter because the payoff is gonna be the same. And this is kind of the same scenario that we see in the last example. Alice would like to choose a strategy that Bob cannot counter, and that's because the payoff is gonna be the same in both scenario. So we can kind of see this. Eventually, no matter where, wait, I thought this is green. Okay, let me make it green. No matter how Alice chooses the X value, if it were to be pink line or purple line or anywhere in between, Bob will just end up picking the smaller number. So the outcome of the game is gonna be just somewhere along this little kinky line here. Yeah, it's gonna be somewhere along the blue highlighter. Now, let us put ourselves in Alice's shoes. Okay, so let's take a look at this green highlight. So now let's put ourselves in Alice's shoes. And she looked at this blue, not blue, the green highlight. And remember how Alice likes large number. And she looked at this and said, well, remember that Alice can choose the X value. So the best thing that Alice can do is that Alice should choose the X value so that the green highlighter is the biggest that it can be, which is basically where the two graphs meet. Yeah, if Alice chooses this X value, I kind of ran out of color. I want to use pink, but I already used pink somewhere else. Let me actually kind of use green momentarily. So Alice can kind of see that because she can choose the X value to be anything. So why should I choose the X value to be 0 when the payoff is gonna be so low? If she chooses this blue, if she chooses this green thing, she has to pay Bob $3. Why would I want that? If she chooses this, then well, she has to pay Bob. She's not gonna get anything. Yeah, why would I want that? She rather choose this exact value where the point on the green highlighter is the tallest. So that means she can get the highest amount of money from Bob. Yeah. And if we were to compute this, we have to use a little bit of the geometry. So I have this kind of graph here. And if you were to notice, these two triangles, they are actually similar triangles. So that means if I look at the base of the larger one, this is 5 units. And the base of the smaller one, this is 3 units. And that means the ratio between the height of the two triangles is going to be 5 to 3. So if this is 5a, this is going to be 3a. But because this whole thing is 1, so 5a plus 3a is going to equal to 1. So that means a is gonna be 1/8. So what that means is at this value, the value of 5/8, the x value is gonna be just 5/8. So in the end, the x value should be 5/8. So I can conclude that Alice, let's see, Alice plays S1 with probability 3/8 and then S2 with probability 5/8. Remember how the x value is the probability that Alice plays S2. And we can kind of compute the payoff of the game as well. Now, if Alice plays S1 with 3/8 and S2 with 5/8, I can kind of use the expected value from any of the two columns here. Let's use the first column. So if Alice plays the top row with probability 5/8 and then bottom row with probability 3/8, then the payoff is just going to be, let's see, 2 times 3/8 plus 0 times 5/8, and that's going to be 3/4. So that's going to be the payoff of the game. So this is Alice's analysis on how she should play the game. Let's kind of do the same thing for Bob. So let me do it a little quickly now then. So for Bob, he kind of do the same thing here, but we're going to do it in reverse now, because the probability is going to be between 0 and 1, and this is going to be the probability that Bob plays T2. And Bob plays T2. And then, so if it is 0, then that means Bob plays dark blue for sure. And if it is 1, then that means Bob plays light blue for sure. And then, if Alice were to play S1, then let me use it in pink. Then that means we will have this pink dot here. And then let me actually kind of color code this. So if Alice were to play S1, and Bob plays dark blue, it's going to be 2. And if Bob plays light blue, it's going to be -3. So it's going to be -3. So now what this means is Bob can choose. So it's going to be Bob and Alice is now going to play the reverse role. Bob is going to choose the probability. Bob is going to choose the value on the x-axis here, which is the probability that he's going to play T2. And then Alice is going to choose between the pink line that I have just drawn and the purple line that I'm going to draw next here. If Alice choose bottom row, which is the purple line, and Bob choose T1, the payoff is going to be 0. And then if Alice plays purple and Bob plays light blue, the payoff is going to be 3. So the y value for the pink line is going to be the expected payoff if Alice plays top row, and the expected value on the purple line is going to be expected value when Alice plays bottom line. And we can kind of use the same strategy here. Bob can reason himself like this. If he plays, maybe I can move this up a little bit so I don't have to zoom out so far. Okay. If he plays T1, that means he's here. And he knew that Alice likes big numbers, so Alice is gonna pick the top thing. Now, if he plays light blue, which is this axis here, Alice is gonna play purple, which is 3. So yeah, Alice wants money from Bob. So Alice is gonna pick whatever the bigger number here. And you can kind of see how it's the same analysis here, but it's gonna go in reverse, because earlier Bob Bob prefers smaller number, but Alice prefers larger number. So no matter what Bob did, Alice is just gonna look at the two choices that she has between the purple point and the pink point. So yeah, Alice asked herself, should I rather get money from Bob, which is the purple thing, or give Bob some money, which is the pink thing. And I rather get money from Bob. Yeah, let's use this one. And she gonna do the same analysis. So she will pick whatever bigger number, and you can see there is an exception where these two graphs meet. So where these two things intersect, that's gonna be when Alice no longer has a choice, because what she does doesn't really matter. The payoff is the same. Now then, the graph for Alice is gonna look like this. She will choose the bigger number between the two. And now, we're gonna do the same analysis. If we put ourselves in the Bob's shoes, so Bob, look at this graph, and remember again that Bob prefers smaller number. So he would like to choose. Wait, what did I draw? This circle thingy thing. Wait, I don't know when I draw this, but I probably don't need this now. Okay, so Bob has to choose the x value. So Bob can choose the x value, whichever frame that he wants, so that the value is the smallest. And you can kind of see how the value is that it's going to be smallest exactly when the two graphs intersect. Yeah, so Bob can do the same thing that Alice did earlier. Let me kind of draw the similar triangle here. The smaller triangle, the width of the base is 2, and then for the big one, this is 6 units. So again, I have 2a, and this is 6a. This has to add up to 1, so that means a is going to be 1/8. So that means the x value here is going to be 2/8. Okay, let me kind of move this out of the way. So in the end, Bob should place T1 with probability, let's see, 6/8. So let me actually write that as 3/4. Remember again, because my axis here, this is probability that Bob is going to play T2. And then he plays T2 with probability 1/8. And then the payoff. Now then, if he play T1 with probability 3/4, and play T2 with probability 1/4, yeah, so 2/8 should be 1/4. So the payoff for Alice is gonna be the same for either option. So if Alice play S2, the payoff is gonna be 0 times 3/4. Wait a minute. Oh wait, that's right. So 0 times 3/4 plus 3 times 1/4, which is going to be 3/4. And this is indeed the same number that we see from earlier. So I can now conclude that this is going to be the Nash equilibrium of this game. And the value of the game, or the payoff of the game, is going to be 3/4 then.